Okay, let's talk about how cluster lifecycle management works across the different editions. It's essentially the same thing. If there's some implementation details, we'll go through over the next slide. But essentially, all the editions of TKG have a management component, right? And the management component provides your cluster as a service. It receives a request to go create a cluster, and then it prepares the information, deploys the virtual machines. It deploys the Kubernetes software on top of the virtual machines, gets them all, gets the certificates all met up so the clusters, the Kubernetes clusters all join securely, and gets it all ready to where you can log in and start using the cluster, provisions the cluster for you. And then after the clusters are provisioned, the management components go out and monitor the clusters themselves, as well as key processes that need to be running in clusters to just to provide a check for cluster health, and they can take basic actions to try to do automated healing and remediation if they find problems. Right now, one thing that's good to note is that the primary difference between the editions, as we'll see over the next slides, is that the management components on the back end are implemented a little bit differently. But the Kubernetes now the management components is, again, these are really for providing your Kubernetes clusters as a service from a platform perspective. But you're providing them to deploy an application. Maybe a user or a development team needs a Kubernetes cluster, right? You provide one for that. Maybe you're preparing a Kubernetes cluster to run some production application on, right? And you may create a workload cluster for that. And so regardless of which edition you're using, you're still running the same Kubernetes out at the in the workload or Kubernetes clusters here. And it's the management components that will change a little between the editions. So let's look at what that is. So first one is that Tkg Integrated Edition. Is our first offering, VMware's first offering into Kubernetes, right? It uses open source Cloud Foundry BOSH and Cloud Foundry Container Runtime to build and deploy Kubernetes clusters. And so when Kubernetes was first released, and I think, still to this day, there's a lot more options now, but if you need to have some sort of system to be able to set up and deploy and manage your Kubernetes clusters. It's not really viable and it's in any scale to say I can go to manually go and build and configure and deploy. And so really, Cloud Foundry BOSH was very well primed for this. It had already done the same sort of thing. Like if you look, what is a Kubernetes cluster? Typically, it is software that's installed typically on virtual machines, right? And that software usually involves an orchestration component and container hosts. And so BOSH has already been doing essentially the same thing, building the virtual machines for very, very similar types of software. And so it's easy to utilize this Cloud Foundry Container Runtime, which is a set of recipes and components, if you will, to empower BOSH to be able to go ahead and create and manage Kubernetes clusters. And so Integrated Edition works essentially the same way. You say, I want a Kubernetes cluster, and it'll go out and build it for you, monitor it for you, and help with the lifecycle management and upgrades, self-healing, etc. And so with TKG Multicloud and TKG Service both, they're utilizing a very new project in the Kubernetes community called Cluster API. So while it's new, it's had tremendous popularity. Right? There's It's not a generally available feature in the open source Kubernetes community at this time, and so support for many infrastructure providers is still new. But I think almost everybody's been committed to the Cluster API project, so it's going to really, you see it really growing massively, and over time really becoming the norm by which this sort of cluster deployment and lifecycle management is done by. And so VMware has been really among the lead developers of Cluster API technology, and so we have a very advanced implementation, mature, that's we've had out for a while now. We also have offer our implementation is we have a supported implementation with AWS and with Azure, that is where you can run. Utilize the Cluster API to provide these management services in production environments. And so we'll get into, over the next several slides, a little more detail and even more in the next section about how the cluster API components work in detail. So let's see, I'm going to go ahead and skip past this. Okay, Integrated Edition architecture. And so with Integrated Edition, we have our management plane. Our management plane in Integrated Edition are virtual machines that have the VMware TKGI software and Bosch installed on them. And so they're able to send a CLI command or an API request with either maybe flagging a pre-specified plan, small, medium, large, for what size or type of Kubernetes cluster. Do I want a dev? Do I want a prod cluster, et cetera? And or you can specify include manifest files. In this case, we're going to include the Bosch. These will result in the management plane here, preparing Bosch manifest, and then getting Bosch will build an OVIA from source for the virtual machine nodes that will power your Kubernetes cluster, and then deploy them onto either the vCenter or the supported IaaS environment. And again, monitors the deployed services and can take self-healing corrective actions, and as well as alerting for any issues that are experienced. And TKG multi-cloud architecture. So very similar conceptually, except here in the management plane, we're using Kubernetes itself, and really, and not even so much running applications on top of Kubernetes before these components, but you can use the use of custom resources. Kubernetes is very popular to actually utilize Kubernetes capabilities itself and kind of build these control objects into the Kubernetes framework. And so we have a lot of those custom resources deployed in these controllers. And so we're able to use TKG CLI, or you can make API calls as well to the management cluster. It will prepare manifests for our cluster API types. We have like machines and machine sets and Kubernetes clusters that it can prepare manifests for, and then it will go ahead and deploy those across the supported IaaS using cluster API technology. Okay, and last but not least, here the TKG integration with Tanzu, Tkg Service. And so in Tkg Service, when you load VMware vSphere 7, there's an option you'll see in the vSphere client called Workload Control Plane. And it's disabled by default, right? Unless you, and then if you've purchased the vSphere or with Tanzu appropriate licensing, you can click Enable on that feature. And it'll go ahead and it'll apply this thing called a supervisor cluster. And that includes a Kubernetes cluster. However, as I mentioned before, with vSphere 7 having Tanzu embedded, that unlocks some additional capabilities that are not present in the standard TKG management cluster that's deployed on other public clouds or on a different version of vSphere. Right? This is really something it's unique to vSphere 7. The supervisor cluster, being a Kubernetes cluster, can run the same management components, right, as the TKG management cluster. But in this case, since this cluster has other attributes as well, we will say that the Tkg service runs on this supervisor cluster. And so just like the Tkg management plane, it's utilizing cluster API to be able to, when you say I want to request a cluster to be deployed, you can specify that manifest by using the well-known cluster API manifest for the some of the cluster deployments, right? And you can, and it'll then use cluster API to set up the clusters just as in the same way that it works on multi-cloud, with a few exceptions we'll talk about as we get into the next section.